Thank you very much. Hello again. So I changed my talk because I thought it would be useful to talk about something different. And I thought it would be useful, interesting for you to know a little bit about WASH, water, sanitation and hygiene interventions for nutrition. And what I'm going to do is talk about a systematic review that we conducted under the Cochrane collaboration, which was published last year, on the evidence linking water, sanitation, hygiene interventions with nutrition outcomes. And I'm going to bring up several of the points that have been raised by Keith and Patrick already. So first of all, the study was funded by DFID under something called the SHARE Consortium, which is a consortium run out of the London School of Hygiene and Tropical Medicine on hygiene, sanitation and water. So there is, of course, an evidence paper published by DFID on water, sanitation and hygiene that gives us these startling facts. 2.5 billion people don't have access to improved sanitation, 780 million people don't have access to improved water, and diarrhea causes 750,000 child deaths per year. And the evidence paper suggests that says that there's good evidence that inadequate WASH contributes substantially to diarrheal disease mortality. So making a strong link between WASH and diarrhea. So this is something that there is very good evidence to support now. We know from multiple systematic reviews that poor WASH, poor water, sanitation, hygiene is associated directly with increased risk of diarrhea. Now, the problem is, of course, that as nutritionists, diarrhea is interesting, of course, but we really want to know, what does it do? Is it important for child health? Does it affect nutrition outcomes? And we know that diarrhea is associated with nutritional status, but of course, we don't know the causality. We don't know whether diarrhea causes poor nutritional status, or whether if you have poor nutritional status, you're more likely to get diarrhea. There has been a very nice analysis of longitudinal studies by Checkley, which suggested that there is a sort of directionality in this, in that your odds of being stunted at age 24 months was raised for every 5 episodes of diarrhea you had prior to being 24 months of age. So it's sort of directionality. If you have multiple episodes of diarrhea, you're much more likely to be stunted at age 24, suggesting that age 24 months, suggesting that there is this directionality. So if we can therefore improve WASH, we should reduce diarrhea, and therefore there should be a benefit for nutrition. So that's really the question that we wanted to ask in our systematic review. So let's just have a quick look at the conceptual diagram, and this goes to what Keith was saying. What is our research question? What's the rigor of our research? Why are we asking this question? And you can imagine the direct linkages between water, sanitation, hygiene, and nutrition outcomes. Poor sanitation, poor water quality, poor hand washing leads to, for example, fecal contamination of the home and of food. That leads to increased risk of nematodes, so worm infection, environmental enteropathy, which is the sort of leaky gut syndrome that is now the subject of considerable amount of research. And of course, as we've just said, fecal contamination leads to increased risk of diarrhea. And you can make a case that all of those three is likely to be associated with poor nutritional status in children. So those are the direct linkages. Of course, there are also multiple indirect linkages between water, sanitation, and hygiene and nutrition outcomes. And these are very important to remember. So for example, if you have to walk a long distance to collect your water, you don't have as much time to look after your child. And that might itself be a predictor of poor nutrition outcomes in children. If you have to buy your water from a street vendor, then you might not have enough money to buy the right food for your child, which also might lead to poor nutrition outcomes. So you always have to remember that there are multiple links between your intervention of interest and your outcome. And it's always, I find it hugely useful to draw these conceptual diagrams of the linkages so that you can really think very carefully about the question you're asking. So back to the diagram that was stolen earlier. with this one. We have, this is the evidence pyramid, and at the bottom you have expert opinion, of course, and Rolf ended with RCTs at the top, but actually at the very top of the evidence pyramid, of course, is systematic reviews, bringing together the available evidence, and it's a really critical step, as we heard as well from Patrick, a really critical step in understanding evidence, because we have a saying in English, one swallow doesn't make a summer. So just because you see a swallow, the little bird that's flown over from Africa that only comes to England in the summer, just because you've seen one, it doesn't mean that it's summertime in England. You have to see lots of swallows. So if you're looking at evidence, if you just see one randomized control trial that tells you this piece, this is the answer, you must be very careful about believing it. You should look at the evidence, you should think very carefully about the evidence, but you should wait until there are other studies that confirm that finding. And it is very frequently the case that there will be one small randomized control trial that says, this is the answer, here's a very strong effect. And then when that study is repeated, and it is done bigger and it is done better, the size of the effect almost always decreases to a much smaller effect. So just because there's one study saying there's evidence to support an intervention doesn't mean that that is true. So you should bring the evidence together in a systematic review. It's a hugely powerful tool. So what we did was we brought the evidence together on WASH, the evidence that water quality, water supply, sanitation, hygiene practices affects nutritional status. We brought it together in one systematic review under the Cochrane collaboration. We did this there are lots of different Cochrane collaborations for different outcomes. And this particular Cochrane collaboration is called the Public Health Cochrane Collaboration, and they allow you to include any study design in your analysis, which is quite important because a lot of Cochrane collaborations focus almost exclusively on randomized control trials, which is very important, but not all good evidence comes from randomized control trials, so it's important to think about the multiple sources of evidence when you're looking to try and understand the totality of evidence. So we conducted a systematic review with meta-analysis, and of course, as we've heard, the benefits of systematic reviews is that they bring together the totality of the evidence, all of the evidence that's ever been published, in a very, very systematic way. The advantage of that, of course, is it reduces bias. For example, I think Patrick is a brilliant researcher. I don't think Keith is a very good researcher. So if I'm doing a systematic review, I like Patrick, I think he's really good. If I'm doing an ordinary review and I like Patrick, I will take Patrick's papers and put them in my review and say, look, that's the answer. And I ignore Keith because I really don't think he's very good. But of course, that's bias. That's introducing a huge amount of bias because I will only hear Patrick's view, I won't hear the totality of the evidence. So in a systematic review, you have to say, what has everybody said? I want to know what everybody who's ever asked this question has said, whether I like them, whether I don't like them, whether I think they're good researchers, whether I think they're poor researchers. I want to know what everybody has said. And you bring it all together, and then in that way, you reduce a very, very important source of bias, a selection bias, selecting the studies that I want to review. So if you say, I will take everything, that's a really important thing to do. And the second thing you're doing when you're bringing together evidence and then doing a meta-analysis is you're increasing the precision of your estimate of the effect. So if you have one study, it might say this is the answer. But if you have multiple studies, then you'll find that the answer is not actually up here, it's somewhere in the middle. And it increases your ability to be precise about how important, how strong that evidence is. So we conducted a systematic search. We looked at all types of WASH interventions, and there are multiple interventions which I'll show you. We looked at all studies that included children under the age of 18 years. We looked in 6 English databases and 3 Chinese databases. We looked in books, conference reports, and we contacted authors directly, and this is something I'm going to come back to again later. Actually writing to authors, saying, you've written this paper, can you tell me stuff? Have you written any other papers? Do you know of any other papers? Is a really important way of finding out evidence, and gathering evidence. The primary outcomes we were interested in were wasting and stunting, and then we had secondary outcomes of height and weight. So that's another really important thing. When you do a systematic review or when you're conducting any study, as Keith said, you need to define the question and you need to define the answers you're looking for beforehand. You need to say, what are the variables that I'm looking for? You need to pre-specify that so that you don't say, you don't midway through your study or once you've got the data say, well, I was at the beginning interested in this, but that's not actually that interesting anymore. I'm now interested in this. That's bad science. Good science is you say at the beginning, I'm interested in this question. I'm interested in knowing whether A impacts B. And then you stick to that, and you stick to it all the way through, because that's what you've designed your study to do. You're being open, you're being transparent, you're being honest about what you're doing. Bad science is when you say, at the beginning I was interested in A versus B, but I looked at the analysis, it wasn't significant, so I'm not going to do that anymore, I'm going to do this one over here. That's very poor quality science, and that's something you should always be aware of. Be very careful. So you pre-specify what you want to do. You make it very clear at the outset in a protocol. So when you do a Cochrane review, you have to write a protocol first, and you have to publish your protocol, and you have to pre-specify what's your question, what are the variables you're interested in, and how are you going to do your analysis. You have to have an analysis plan, as Keith said. So when we did our search, we identified, as you always do when you do such a massive search in all these different databases, 20, 30,000 papers, I can't remember what it was, and of course we only found a very small number, and we found 14 studies which were conducted in 10 countries. And in those 10 countries, as you can see the list of countries there, and the studies were, some of them were very short, 6 months, and some of them were a bit longer, 5 years, and the total sample of children available was, in the study was close to 10,000. Remember I said that we wanted to, any study on children up to 18 years of age, but no one had ever studied children up to 18 years of age, so all of the data are available on children up to 5 years of age. We did, as Patrick said, we looked at the quality of the studies. Now, think about these interventions. These are interventions on water quality, water quantity, sanitation, and hygiene. So one of the critical criteria for quality is called allocation concealment. Did you hide from the participant what they were getting? So if you think about a clinical trial where you're giving a tablet, you can hide what they're getting because you can make tablets that are identical, except one has the active ingredient and one has a placebo. You can't hide a toilet. Yeah, you can't. The person who gets a toilet in your intervention knows that they're getting a toilet. They know that the water is coming into their house. They know that they're getting soap to wash their hands with. So all of the studies failed. They're not high-quality studies because you can't conceal the intervention in WASH studies. And this is a real problem. This is a significant problem. Why is it a problem? It's a problem because if the participant knows what they're getting, it can influence the outcome. And that's really, really important. If you know you're getting something, then you might, and you know why you're getting it, then you might think, actually, yeah, actually I do feel better. I didn't have diarrhea, and my child didn't have diarrhea. And thank you so much for giving me the toilet, and I know you want me to say that I didn't get diarrhea, so actually none of us have, we've never had diarrhea. Okay, so that's a real source of bias, which is very, very possible in studies where you can't conceal, where you can't hide the intervention. And that's a problem. In some of these big studies with big, complex interventions, how do you hide studies? How do you hide the intervention? So we also had multiple study designs. Now, of course, we had some lovely cluster. Oh, and one other thing I wanted to say, sorry, I'm going to go back, which is about study quality. One of the things you can do, and one of the things you should do when you're doing a systematic review, is get on the telephone and ring the authors of the studies, or write to them an email. So if something is unclear, you know here you've written X, Y, Z, do you actually mean that? Can you tell me exactly what you mean? You can ring them up, you can write to them, and you can say, and good scientists will respond, and they will clarify what they did. And it's a really important step. And what also you can do is you can say to them, you know you've published these outcomes, but I also know you've got all these other outcomes that you didn't publish. Can you let me have those data? And in fact, as I'll show you, everybody sent us all of their data, raw data, which is an enormously powerful thing as well. And that's about transparency, that's about honesty, that's about openness. And that we are now moving into an era, and I've been talking to Rolf and Patrick about this as well, we're moving into an era where we need to be very open with our data. If I collect data on you, it's not my data, it's your data. So we need to, and there's a very strong global movement that there should be immediate open access data. When I collect data, it should be available openly. And when you publish in the top journals now, or when you get funding from some major grant-giving bodies, they insist that you make the data publicly available. Often, I know of a study that looked at brain function, an absolutely massive study, and they knew from day one that they would have so much data they wouldn't know what to do with it. So they took brain scans of 50,000 Americans, and as soon as the machine had finished taking the scan, the data went onto the web, and anybody anywhere in the world could use it, because they knew they would never be able to use all this data, so they should make it available. So you can access these data by you should be able to access data by asking people for it. So we had multiple different study designs, cluster randomized controlled trials, follow-ups, longitudinal studies, and this was a systematic review, as I said, where we really wanted to know what is out there. What is the totality of evidence? And you can see we had multiple different things, very complicated study designs, some of them, and of course there are problems with each of these study designs. Some are much stronger than others, some give you much more cause to believe the answer, some have much greater bias, risk of bias, and you need to be aware, as Keith said, about the rigor of these designs. We also had multiple interventions, and I was influenced here by the people I worked with in this systematic review about what is important in WASH. So some people say it's all about having a loo. Some people say it's all about having water. Some people say it's all about giving soap. And other people say, actually, WASH is WASH. It should be one package. You should get water, you should get a loo, a toilet, and you should get soap, because all of them are important. And we, as a movement on WASH, we want everyone to have access to everything, not just the soap, not just the water. So in the end, we combined all of these interventions together and called them WASH, and said, what's the effect of WASH, and that's any of these things, on nutrition outcomes. Now, when you have multiple different study designs, you have to be very, very careful about your analysis, because you can't combine data from a controlled longitudinal study with data from a randomized controlled trial. It's very difficult and a difficult thing to do, and you should be very careful about doing it. So when we conducted and when we reported, if you have a look at the report, it's available on the Cochrane library. I'm sure we can circulate it as well. We said we reported the findings from every single study in a standardized way, and then we said we want to do put all of the data together in a meta-analysis, but we can only put the data together in a meta-analysis from the studies of the same design. And it really only makes sense to do that, to bring together the same design of studies when you're doing analysis. Now, we did two different types of analysis. One is the study level analysis. There were 5 cluster randomized controlled trials. So the N in the study level meta-analysis is 5. However, as I say, we asked all of the authors of those 5 studies for their data, and they gave us their data, and then we got the raw data on 5,300 children. We put all of that into one analysis. We combined all of the data sets and put it all into one analysis, and we can do a really powerful thing called individual participant data analysis, where rather than having an N of 5, you have an N of 5,000. Really, really powerful thing. And that's because we asked people for their data. So if you look at the N equals 5, and there are more than 5 studies here because they're split up because they have complicated designs, but let's not worry about that. This is the forest plot, and you can see that if all of the dots are on this side, then it would be the WASH would be improve weight for height, and if all the dots are on here, then WASH would have a negative impact on weight for height, and you can see that basically they all lie on the line of no effect, suggesting that wash does not change weight for height. Okay. When we did the same for height for age, you can see that all of the dots lie to the right of the line, and the pooled effect there is slightly, it touches the line as well, so it's suggestive of an effect, suggesting that wash improves growth in children under the age of 5. These are randomized controlled trials. Okay. What we then did, as I say, is the individual participant data analysis. So we have data then on 5,500 children. You can run them all in one analysis. You can adjust for age. You can adjust for sex. You can adjust for duration of the intervention. You can adjust in one analysis. It's much, much more powerful. And you can see again that we found no impact of wash on weight for height, but we found a stronger effect of wash on height for age. And in fact, with this, I'm not reporting it here because it's a subgroup analysis. You always have to be very careful about subgroup analysis. I can come back to that if you want. Very careful about subgroup analysis. But what we found was that wash improved growth by 0.1 Z-scores. So not a huge amount, but it was a significant effect. But if you looked at children under the age of 24 months, wash improved height for age Z-score by about 0.2 Z-score, so doubled the effect. So the effect was stronger in younger children, as you would expect. So the IPD, having the individual data, allowed us to do a much more complicated analysis. It was much stronger statistically and gave us a much richer finding. So our interpretation is that this is the first systematic review looking at the links from wash all the way through to nutrition outcomes, not just stopping at diarrhea. We've identified a reasonable number of studies. However, none of the studies are very good quality because, as I say, one of the main reasons was you can't mask, you can't hide these interventions. There's suggestive evidence, we've said, throughout the paper and in everything we wrote. The evidence is suggestive. I'm not saying it's strong evidence. I'm not saying it's weak evidence because we've got a nice body of data, but it is only suggestive. It suggests that there may be a benefit, and we are aware of multiple studies that are currently underway, which we will include when we redo this analysis. And the thing about Cochrane, this Cochrane review will stay with me until I die, as I've done another one as well, because when you do Cochrane, you are obliged to update it periodically. Every 3, 4, 5 years, they insist that you update your Cochrane review. You can't get rid of it. So I might change my name, actually, but no. But so you have to update it, and that's again really important because it's relatively straightforward to update. You've done all the conceptual thinking, you've done all the work, you've written the analysis plan. You need to get the new data, put it into the analysis, rerun the analysis, and then see has the evidence changed over time. And that's really important. That's about the accumulation of evidence and the fact that that the answer changes over time. And that's an important thing, as that's how science develops. And that's the importance of good quality evidence. Right. Thank you all very much.